This is the second video of a 6-part series where I'll be going over the free response questions on the 2021 AP Calculus AB test. Now, just like in the last video, I will give a link to these questions as well as the scoring guide in the description. So with that out of the way, let's get into the problem. So here it is. Before we start though, I recommend that you pause the video and go through all these problems and just see how far you can get. Hopefully that went well for you, so let's get into part A. Okay, so a particle P is moving along the x-axis. The velocity of particle P at time t is given by this function for the domain 0 to pi. At time t equals 0, particle P is at position x equals 5. So time equals 0, this is going to be our initial position for particle P. Then a second particle Q also moves along the x-axis. The velocity of particle Q at time t is given by this function for the same domain, and at time t equals 0, so the initial position again, particle Q is at position x equals 10. And then part A asks us to find the positions of particle P and Q at time t equals 1. So we know that the interval that we're going to be dealing with is going to be from 0 to time equals 1, right? And the way that we find the distance traveled in any particle is by taking the definite integral of the velocity function up here. So what that's going to look like, since we know that we're solving for the positions of these particles, let's just start with this first P particle here. So x of P of t, xp of t, and I got that from up here since we're using Vp of t. And actually, this would actually need to be xp at 1 because we know that we're dealing with when t equals 1. So this equals, and then we need to remember to take into account our initial position, which is particle P is at position x equals 5. So we're going to start with the 5. Then we're going to add the distance traveled, which again we can write with the definite integral of Vp of t dt. And then our bounds, we know that we're working from the domain of 0 to 1. So there's our setup. Just by writing this definite integral, right, we can score a point even without this 5. Just writing this down will score you a point. So just keep that in mind. So if we plug that into a calculator, we get 5.371. So the position of particle P when time equals 1 is going to be 5.371. So moving on to the position of particle Q at 1, it's going to be the same thing. Just like up here, we need to start with our initial position, which is x equals 10. So 10 plus, and then just like last time, we're going to take the definite integral of the velocity function for Q. So Vq of t dt, and then our bounds again is just going to be 0 to 1. So 0, 1. And keep in mind for these, you do not need to write out these full functions, right? It's a lot better just to, if these are defined and here we know that they are defined, we can just use these names that they gave us. So there's really no need to write out this entire function. So then back to what we were doing. If we plug this into a calculator, we get 8.564. So here are our two answers. Hopefully that problem went well for you. Moving on, are particles P and Q moving toward each other or away from each other at time t equals 1? Explain your reasoning. So for this one, in order to find which direction the particle is moving, we need to tell whether the velocity functions, whether they give us a positive or negative value. So let's start with P. Vp and we know that we're working with time equals 1 again, 1 right there. So this is going to equal, if we just plug in the values into this equation, that's going to be sine of 1 to the 1.5. And already in your head, you can kind of tell, since the number inside the sine function is between 0 and pi, that this is going to be positive. So it's going to be a positive function, which means on a number line, it'll be moving to the right. So for particle q, let's do the same thing for when time equals 1. Again, we're just going to plug in 1 for t into this function. So that's going to be 1 minus 1.8 times 1.25 to the 1 power. So 1.25 to the 1 power is just going to be 1.25. Then 1 minus 1.8 is going to be a negative number, and we know that a negative times a positive is going to be equal to a negative. So this is going to be negative, which means we're moving to the left. So now we have the directions that the particles are moving. And if we recall on our previous problem, let me just draw a number line. Particle P was at 5.371, and particle Q was at 8 something. So Q 8564. So particle Q starts out on the right and particle P starts out on the left. And if P is moving to the right, and Q is moving to the left, then we know that they are moving toward each other. And in the scoring rubric, they actually tell you that you need to give some sort of explanation. And even if you don't give it verbally, or excuse me, even if you don't write it down in words, you can still draw a picture like this that shows them your thinking, and you can still get full points for this problem. All right, so part C. Find the acceleration of particle q at time t equals 1. Is the speed of particle q increasing or decreasing at time t equals 1? Explain your reasoning. Okay, so for this first part, we're asked to find the acceleration of particle q, so we're dealing with this equation. And we know that the acceleration is given by the derivative of the velocity. So let's just write that out here. The acceleration is going to be equal to the velocity prime. And writing this out will tell the AP graders that you know that the derivative of the velocity is acceleration, so this will earn you a point. So from here, let's actually find what the acceleration at time t equals 1 is. So a of 1, if we plug that into a calculator, we will get 1.027. And it's important to note that this is going to be positive. So here is the answer to our first part. And for the second part, is the speed of particle q increasing or decreasing? So since we're dealing with speed, we need to tell whether the signs of the velocity and the acceleration are the same or are opposite. So what I mean by this is if we take a look at the velocity of particle q, and let me write q up here too, just so we can be really specific in our answer. So our velocity at t equals 1, it was actually negative. It was negative, right? And this, we know that it's positive. And if we compare the acceleration and the velocity at this time, we can see that the signs are opposite. So we can write that the speed of particle q is decreasing at time t equals 1 because the acceleration and velocity have opposite signs. So there is part C. All right, so our final part, find the total distance traveled by particle p over the time interval 0 to pi. So for here, we're dealing with the total distance, which means we have to deal with when the velocity was also negative. So how we set this up is the total distance is going to equal the definite integral from, and since we know that we're dealing with the domain 0 to pi, our bounds are going to be 0 to pi. And since we're dealing with total distance, we know that we need to deal with absolute value. So let me just open that here. And then we're dealing with particle p, so I'll just write the velocity function. Then close the absolute value. then dt. And if we plug this into a calculator, we are going to get that the total distance traveled by particle P is going to be 1.931. So for this one, this was pretty short, but setting this integral up as well as giving the correct answer will score you 2 points on the AP exam. Hopefully these problems weren't too bad for you. If you do have any lingering questions, you can leave them in the comments, or you can send them to me in my email, which is in the description. I will also, again, put the links to the FRQ as well as the scoring rubric in the description. And our next video is going to be a no-calc question.